Assalamu alaikum guys. Today we are going to study another new chapter, the periodic twins in atomic radii and the periodic twins in the ionic radii. I am Najmanisha Ashar. So I came to explain you about the periodic twins in the atomic radii and the ionic radii according to the S and P block elements. So this is how it shows the major impact in your atomic structure. Let's move on to the chapter now. Before start this chapter, we will go through the contents. The first thing we are going to speak about what the periodic twins in the atomic radii. So whatever when I say that name called the periodic twins, that is very important how we are going to explain the periodic twins in particular chapter. So here we have selected two things. One is the within each group and within each period. Actually, the last before presentation we have gone through what is the periodic table, what is called the column. The column is a group, the row is a what period. We have studied all materials according to that. Now we are going to speak about what the periodic twins in atomic radii according to the S block and P block elements. Second one, the periodic twins in ionic radii. Atom means what? The neutral atom. Ion means what? Either it can be what? The cation or anion. If it is losing the electron, that is cation. If it is accepting the electron, that means they are anion. So now, according to that manner, we are going to speak about how it's focusing, how it's showing the major twins in the periodic action, right? So here we are going to speak about cation, anion, and there is another word called isoelectronic ion. So let's move on to that. This should be new. The word called isoelectronic ion we will study later, right? The first thing we are going to speak about the periodic twins in atomic radii. The atomic sizes with the periodic table show two interesting trends. I already said right under the contents. But before that, our last presentation, we have studied about the different type of the size of the atom and ion. Yes, according to that, if you want to explain about the atomic sizes, there is no definite shapes, right? So you couldn't say like that. According to that, we are speaking the three types of the radius we have studied there. That is what? It's a covalent radius, van der Waals radius, and metallic radius. When you speak the van der Waals radius, we are telling that is non-bonding radius, covalent radius is bonding radius, and metallic radius as well as you know that is what the metals form the bond. So according to that, now you know what they are speaking about the radii. We already spoke about that. And here they are going to use the two different interesting trends. What we have studied and what I go through in your content. Yes, the first one is within each group. Each group means what, guys? Again and again I'm telling. Now you should be very familiar about what the trends and the periodic table, right? So when you go for the each group, right? So what is happening actually? The atomic radius tends to increase from top to bottom. Simply you can say the atomic radius is increasing down the group. The word is very clearly you can see. Right. So this trend results why the primarily from the increase in the principal quantum number n of the outer electrons. Yes, what is meant by the principal quantum number? Your number of shell is increasing. So when it happens, the down the group, that means what? The number of shell is increasing. Therefore, what is happening? Your nucleus distance between the nucleus and the valence electron also will be high. That tends to what? The radius also becoming increasing. That's why they are telling down the group, down the column, the atomic radius is increasing. Right. Next one. Within each period. The period Straight means what? You just keep on your eyes that we are talking about what? Along the row, right? So when we speak about the within each period, right, you can say simply along the period or left to right the period. So this is what the word that you have to use for to explain the trends of atomic radius. So the radius, atomic radius, generally tends to decrease from left to right. Word is very important. When you see the left to right, the atomic radius is decreasing. What is the reason? The major factor that influencing the trends, the increasing in effective nuclear charge across the period. As it is moved from left to right, the nuclear charge also increasing left to right. Therefore, what is happening? The increasing effective nuclear charge steadily draws the valency electrons closer to the nucleus, causing the atomic radius to decrease. Simply you can say by using the notation, right? Yes. So what is happening? So this is what your number of shell is increased. Right down the group, what is happening? The number of shell is increasing. Therefore, you can say what the radius is increasing. But along the group, what is happening? The radius is decreasing. What is the reason? The effective nuclear charge steadily increasing. That is what's happened. The valency electron, the attraction between the nuclear effect between the valency electron and the nucleus will be high, steadily increasing. For that sake, what is happening? This atom become little small, that it will shrink, so it will become closer. For that sake, what is happening? Your atomic radius along the period is decreasing. This is the term, right? So trends in an atomic radius in the periodic table in picometer, right? So you can see this is very clearly. I'm just going to explain you one by one. Just let's say use the annotation, right? Okay. So look at this, right? The simply we said as in the group, down the group, top to bottom, the atomic radius is increasing. So you can see size of this. Yes, down the group is increased. What is the reason? Number of electron shell is increasing. Therefore, the attraction between the nucleus and the valency electron will become so far. It will reduce. Therefore, the atomic radius is increasing down the group. So look at here. Along the period. Along the period means simply you can say what? Left to right. What is happening? You can see the size here clearly. The size of the atom is decreasing. Yeah, so as it is the reason, the longer period, the nucleus effect is very high. Effective nuclear charge is very high. Therefore, the attraction also high. So what will be happen? Your atom becomes smaller because of what? The attraction between the effective nuclear charge between your nucleus and the valency electron become more stronger. So therefore your radius will be decreased. This is they are telling, that means what? If you take the right to left, the atomic radius is increasing. So this is simply they are explaining, but by using this periodic table, you should be able to explain by looking this clearly. Even though whenever they have given the number of the atoms by looking, so according to the period and according to the group, you should be able to explain it, right? Next we move on to the next heading. The periodic trends in ionic fluid. Actually, when it speaks about the size of an atom, the size of an ion depends on, first thing is nuclear charge. The second thing is the number of electrons is focused. And third one is the orbital in which valence electron is visible. These are the three factors which is explaining about your size of an atom and the size of the ion. According to that, you can categorize this is up to what for using a cation, right? When you take a cation, what is happening, right? What is mean by cation? The cation which is able to lose the electron from the valency shell and becoming a more stable configuration, right? So that means once it lose the electron, it will become positively charged. This is what we studied in unit 1 earlier chapter, right? According to that, what they are telling is, when a cation forms from a neutral atom, the electrons are removed, right? The electrons are removed from the occupied atomic orbitals and that are more spatially extended from the nucleus. So this is what I said, how the cation is formed. When you take, right, any atom, right, what is happening? It will lose the valency shell electron and becoming more stable configuration. This is how the cation is formed. If it is loses one electron, it will become what? X plus. If it is loses two electrons, it will become 2 plus. This is how it's creating the cation, right? Yeah. What is happening? As it is result. When a cation form, I said is externally from the nucleus. Also, when a cation form, the number of electron repulsion also reduces. Why we are removing the electron from your valency electron shell? That means there is the electron repulsion also, there is a possibility to reduce. So what is happening? Sorry. Therefore, the cations are smaller than their parents. So actually, just keep in your mind, when you take your parental atom, the simply example, take your sodium, right? So what is the electron configuration of the sodium? Yes, you can write it as your sodium. That electron configuration is 1s2, 2s2, 2p6, 3s1. So you can see there is 3 orbitals, right? 3 shell, 1, sodium, sorry. So when you take the sodium, 1, 2, 3. The third one having the electron. This is what your parental electron. But when it is remove one electron, it will become sodium plus. Sodium plus, what is your electron configuration? 1s2, 2s2, 2p6, but no 3s1. So therefore you will have the sodium. What is the configuration? Just 2 electronic shell. So what is happening? The sodium plus having the smaller in size compared to your parental atom. That's why we are telling that is able to the electron repulsion also reduce. Therefore, the cations are smaller than their parental atoms. Right? Okay. Go for the next one. The next one is the for anion. So this is opposite for the anion. The trend is how the anion is forming. Yes, I say As it is anion is for the stability, they are accepting electron. One is accepting the electron, you can see they will become as in the stabilizing form. So when electrons are added to an atom to form an ion, they increase the electron repulsion, not like earlier what it had done, it has lose the electron and become the stability. But now it has increased the electron, therefore the electron repulsion will be high. Therefore, the electrons to spread out more in space. So finally, what is happening? Thus, the anion are larger than the parent. So this is the reason, guys. So when it accepting the electron, right? So the electron repulsion will be high. Okay. So therefore, what will be happen? The ion, the electrons will spread out all over the space. So size of the anion become larger than the parental atoms. So for ions carrying the same charge, both positively or negatively charged ion, the ionic radius increases as we move down a column in a field. So this is very important. You can say commonly that word is very important. Yes, if it is an ion, right, having a same charge, you can say both positively or negatively charged ion. The ionic radius increases as we go down the periodic table. And also, in other words, as the principal quantum number of the outermost occupied electron of an ion increases, the radius of ion also increases. Simply like your atomic radius, right? Your ionic radius also down the group, the number of principal quantum number also increases. That means your number of outermost shell also increase. Therefore, the ionic radius also increases. So the radii of cations and anions compared to the parent atom in Picometer. So you can keep on your eyes. This is what your radius. So what is happening? You can see when you see as usual down the group, the radius of what is increasing. Ionic radius is increasing. Okay, and along the period, the ionic radius is decreasing like your, yes, as like your atomic radius. The Commonwealth is right. So when you take the lithium plus that cation that is red in color, but the parental atom is bigger size. Can you see the difference? So this is what is clearly shown you. So this is the difference what always the cation smaller than the parental atom. But go for the anion, the parent atom is yellow, somewhat the yellow in color. That is middle side. And the blue color, it shows the anion. So this is great results and the beneficiation you can see clearly visualized, right guys? So you can see what is happening. Yes, the anion is bigger than the parent atom, right? So next we will just go through about what? Isoelectronic series. So what is mean by the isoelectronic series? Yes. An isoelectronic series is a group of ions or atoms containing the same number of electrons. The word is very important. What is called by the isoelectronic series? Yeah, the group of ions. So you can say the isoelectronic isoatom, right? The isoelectronic series is what? The group of the isoatoms containing the same number of electrons. So how could be possible? Take an example, right? So the isoelectronic series, yes, your O2 minus. Yes, what is your O2 minus? Your oxygen is 8. Right? When it become O2 minus means is accepting another 2 electron. Therefore, it become what? Right. And take fluorine, F minus. Fluorine, yes. What is the electron? Number of electron presence there 9. S minus, accepting one more. Therefore, it will become as what? 10. Go for neon, right? We know neon, it's a noble gas. It is unable to accept any electrons. Therefore, that is also 0. Sorry, 10. And take sodium. The sodium is what? It's 11. Losing one electron, becoming what? Sodium plus. So therefore, that is also 10. And take your magnesium. Yes, your magnesium is 12. And losing 2 electron, becoming what? 10 electron. So this is what they are telling. Though it's a different series, right? But having what the same number of electrons, that's what they are calling as isoelectronic series. So how it shows the major impact on this, right? So in any isoelectronic series, the nuclear charge increases with increasing atomic number in the series. As the atomic number increases, the nuclear charge increases. Therefore, what? The size of the ion or atom will be decreased. So what is happening? Because of the number of electrons remain constant, ionic radius decreases with increasing nuclear charge as the electrons are more strongly attracted to the nucleus. So simply I say, so when you speak about the isoelectronic species, the nuclear charge increasing the atomic number. The atomic number is increasing, but what is happening? The electron number is constant. Therefore, the nuclear charge is increasing with the atomic number, which reads what? The radius, the ionic radius become decreasing. While the atom or ion is attracted towards to the nucleus more strongly, therefore the radius will become more less. So this could be explained about radiant and isoelectronic series. Yes, you can see here when you take the O2 minus, this is I am talking what along the period, increasing number of what? Atomic number, but having the same number of electron configuration. Yes, your O2 minus, F minus, neon, sodium plus and the magnesium 2 plus, those are having what? The same number of electrons, but what is happening? The atomic number is increasing. As the electrons are similar, the atomic number is increases, therefore nuclear charge effect also increasing. Your attraction between the electrons and the nucleus will be more effective. Therefore, the size of the atom decreasing as the increasing of atomic number. Did you all understand? Right. Okay. This is what we have studied under the periodic trend and the periodic trend of the ionic radii and the atomic radii. Right, guys? So we will go through how shows the major impact of the on your S block and the P block element. And we have studied according to that by having your periodic table. Let's move on according to that, guys. Just for a very view and the brief explanation. This is very important for your examination, right? And keep on your eyes and just go through that notes again and again, and you will be realize why it's really important. And thank you very much, guys. We will see you with another presentation. Until that, see you. Bye bye. Assalamu alaikum warahmatullahi wabarakatuh.